This is our video for Unit 8, Day 2. What we're doing today is looking at applications of the Pythagorean theorem. So yesterday we looked at how we use the Pythagorean theorem to find the third side of a right triangle. Now we're going to use some applications. So by now we've already gone over this warm-up in class. What we see here is we have these 3 points. This is a right triangle on the graph. Right, we can see from the distance between here, this leg right here would be 6 from 1 to 7. This leg here would be 8. And to find this distance here, we can use the Pythagorean theorem. So x is the hypotenuse, so x squared equals 8 squared plus 6 squared. 8 squared is 64, 6 squared is 36. Add those together, we get 100, which means that x is 10. So this is really the same thing we did yesterday, we're just putting a graph behind it, and this is our first application of the Pythagorean theorem. This is called the distance formula. So what we did on this graph, this is the same as finding the distance between these 2 points, 7, 0 and 1, 8. This straight line right here, the hypotenuse of our triangle, that's the distance. So finding that hypotenuse is really the same as finding the distance between the points 1, 8 and 7, 0. So finding this distance, that's the first application we're going to look at today. By application, we mean something we use it for, of the Pythagorean theorem. So we see there's 2 legs, and the distance is the hypotenuse. So the difference, I remember that difference means subtraction. The difference between the x coordinates of the 2 points forms one of the legs of the right triangle, and the difference between the y coordinates forms the other. So if we look at the warm-up, this leg right here, the 6, this is the difference between the x coordinates from 1 to 7. And then this leg here, the 8, this is the difference between the y coordinates, 8 and 0. And then last thing, the hypotenuse. Hypotenuse of the triangle is the distance between the points. So you should have seen this formula in Math 1. This formula right here is called the distance formula. Right, and all this is saying is it's the same as using the Pythagorean theorem. That's the exact same way we find the Pythagorean theorem. So d, the distance is our hypotenuse, If we square that, right, that gets rid of the square root over here. That's equal to the two legs squared, the difference between the x coordinates and the difference between the y coordinates. So the two legs of our triangle are y2 minus y1 and x2 minus x1. And the hypotenuse is d, the distance. So we'll do two examples real quick. First one we'll use the formula and the graph. The second one we'll just use the graph. So it says find the distance between these points. So we have 6, 2, 6, negative 2, and negative 2, 4. So to find distance, first thing we're going to do is graph them. So first we'll graph 6, 2, means right 6, down 2. Then we'll graph negative 2, 4, means left 2 and up 4. Alright, so between these 2 points now we can form a right triangle. Right, using the graph now we can count out the length of each of the legs. So this would go from negative 2 to 6, would be 8, the bottom leg. The top leg go from 4 to negative 2, would be 6. And then this would be our distance here, the hypotenuse. And then we can use Pythagorean theorem. So d squared hypotenuse equals 8 squared plus 6 squared. Solve this, 64 and 36. D squared is 100, so the distance is 10. If we use the formula, it's the same thing. This is a way of looking at it visually, and the formula is a way of looking at it algebraically. So distance is square root x2 minus x1 squared plus y2 minus y1 squared. So here our x coordinates are negative 2 and 6. So negative 2 minus 6 squared. Y coordinates are 4, negative 2. So you have 4 minus negative 2 squared. And then we'll end up at the same place. So negative 2 minus 6 would be negative 8 squared, plus 4 minus negative 2 would be plus and plus. So 6 squared, and that would put us right back here. Alright, negative 8 squared would be 64, and 6 squared would be 36, so we get the same answer. Alright, so there's two different ways you can do these problems. Whichever one makes the most sense, do them all that way. So do the same thing for the second one, 5, 8, and 2, 4. So first thing, we can graph the points, or we can use the formula. 2, 4. And look at the length of the legs from 2 to 5. This one is 3. 4 up to 8. This one is 4. And this is our missing distance here, d. So d squared equals 3 squared plus 4 squared. 3 squared is 9. 4 squared is 16. D squared is 25. So our distance is 5. At the bottom of the page, there's 4 problems there. You can practice those. You can do them using the formula or using the graph. Either way is fine, so whichever way is easiest for you. Next application is determining whether triangles are acute, obtuse, or right based on their side lengths. So this is another way we use the Pythagorean theorem. So if this is called acute, obtuse, or right, is called classifying triangles using their angle measures. So triangles with all acute angles are called acute triangles. If it has one obtuse angle, it's called an obtuse triangle. And if it has one right angle, it's called a right triangle. So use the same notation. A and B are the two shorter sides, just like when we're working with right triangles, and C is always the longest side. And what we look at is see if a squared plus b squared is less than, equal to, or greater than c squared. So if a squared plus b squared is equal to c squared, then it's a right triangle. That just follows our regular Pythagorean theorem. If a squared plus b squared is greater than c squared, then it's an acute triangle. And last one, if a squared plus b squared is less than c squared, it's an obtuse triangle. So here we'll do two examples of would a triangle with the following side lengths be acute, obtuse, or right. So again, it doesn't matter which one we call A or which one we call B. What's important on each one of these, we pick out the biggest side. So on the left, the biggest side would be 6. That would be our C. And on the right, the biggest side would be 12. So on each one of these, what we're going to look at is a squared plus b squared. Look at c squared and see which one is bigger or if they're the same. So on the left, that would be 3 squared plus 4 squared. C would be 6 squared. So we have 9 plus 16, which is 25. We have c squared is 6 squared, which is 36. So here, a squared plus b squared is less than c squared. So we have an obtuse triangle. On the right, we have 10 squared plus 11 squared. That's our a squared plus b squared. And we have 12 squared as our c squared. That's 100 plus 121, 144. So this will be 221. So here, a squared plus b squared greater than c squared. So we have an acute triangle. And then if we had one where the two were equal, that would be a right triangle. If you're looking for any other videos or resources or extra practice with these problems, you can look for distance formula from the first page and classifying triangles for the second page.